20th, 1984. We are taping Dr. Robert Larson, who has had a long and distinguished career in the field of electrical engineering. And so we will now start to tape, beginning with his early experiences, actually bringing him through the schooling, high school, college, graduate school, and into his professional career. So at this time, we would like to start out, and so if you are now ready, please proceed.
Well, thank you very much. Yes, I was born in Stockton, California on September 19th, 1938. And I understand the reason I was born in Stockton, California as opposed to San Jose is that a couple of years before that, the College of the Pacific concluded that San Jose was a dying town. They wanted to move their campus to a really booming town like Stockton. So that's why I was born in that part of California rather than San Jose.
So history has changed quite a bit since that time, and I believe San Jose has grown from somewhat a sleepy town to somewhat larger today.
That's right, and I guess I'm back in the old neighborhood here, just a few miles from San Jose in Silicon Valley. I lived out in California for about 5 years, and then when my father was called to the Manhattan Project in Oak Ridge, Tennessee, we all moved back to Oak Ridge. So I celebrated my 5th birthday in Gatlinburg, Tennessee, and then moved into Oak Ridge soon after, and got all my schooling from ranging from Cedar Hill Grammar School and Jefferson Junior High School to Oak Ridge High School, all in Oak Ridge.
Yes, well, that's a remarkable experience, and I believe you were probably one of the first to take all of your preliminary education all the way through the Oak Ridge school system then.
Yes, I was in the first class that could possibly have had 13 years of school in Oak Ridge, and I was one of about 10 people who had actually had that experience.
Well, that was very interesting. Well, I think probably we might start out with what some of your early interests in the field of science and technology. So, at what stage can you remember that you first became interested in science and technology and first started your, you might say, experiments in this field?
Well, I always had liked math and science, even back in grammar school and junior high school. And I think probably one of the biggest significant things was I attended a lecture at the University of Tennessee when I was a sophomore in high school, where they talked about Boolean algebra and how it could be applied to this problem of the farmer with a boat trying to carry a fox, a goose, and some corn across a river. And the lecture was on how Boolean algebra could actually model that, and then how that might lead someday to a computer that would actually carry out the calculations. And then you showed me an article in Scientific American along the same lines that showed the design of a computer that could actually do this using telephone relays.
Yes. Let's see. What year was that?
52 or 53, I believe.
Oh, yes.
This was well before computers were much established in any way.
Oh, yes. A lot of people had talked about computers, and there were some of the early models on the market at that time. But that was essentially your first application of logic circuits to a computer problem.
Right. It was really interesting because kind of in that concept, the hardware and the software were sort of together. That is, the logic design was what amounted to the software at that time. So it was kind of a combined job of designing hardware and software into an admittedly very simple computer. But there was really no separation of them in those days.
Well, yes, that's very interesting because it was quite some time before really software became separate from hardware.
Right, and I actually designed and built several computers through high school and entered them in various science fairs. And I guess probably the high point of that came at the Tennessee State Science Fair when I was a senior in high school, where I won first prize for the state of Tennessee for computer that essentially multiplied two binary numbers together and translated the answer into a decimal form.
So you had not only the calculations built up, but you also had the translation into decimal system.
Right.
Fine. Well, what other experiences do you remember from high school?
Well, I was very interested in math and science, and I did generally quite well in all my classes. I was valedictorian of the high school. I was also the first National Merit Scholarship winner, and you might say in the whole state of Tennessee and in the whole country. Of course, there was one class that was the first year the National Merit Scholarships were awarded, and I was in that very first class.
Yes, well, that was quite an honor, because I believe the total throughout the country was something like 1,500, I believe, or less.
I think it was even around 600. It was a pretty small number.
And fine. Well, as a result, you then were one of the winners in the National Merit Scholarship contest, and then essentially you really had your choice, therefore, of any school, any college that you wish to go to. And so what led you into your decision as far as college is concerned?
Well, I really had only heard about MIT my last couple of years in high school, but I heard it was the premier school for computers and for electrical engineering and that type of work. And so that's what motivated me to go to MIT.
Oh, yes. I believe you also had a rare experience in that you worked for IBM even the summer before you went to college. Would you care to describe some of your experiences in that respect?
Yes, that was really a tremendous experience for me. In fact, I even went up to Poughkeepsie, New York for a job interview where I saw 6 feet of snow on the ground for the first time in my life. That was quite a shock. And went out to Poughkeepsie, had a job interview, got to meet some of the people there, and I was actually given some of the very first transistors that IBM was making. And it's very possible that I carried the first transistors that ever got into the state of Tennessee when I came back from that. They gave me 3 or 4 of them to play around with.
That's an amazing story, because there were very few transistors in the whole country available at
That's
that
right.
time.
They were just barely beginning to make them on a somewhat experimental basis.
And I believe there were no computers at that time that were actually completed and on the market using transistors rather than vacuum.
No, everything was vacuum tube still. This was the 704 and 705 were the current IBM models at that time.
Oh, yeah.
My first project, the first summer before I went off to MIT, right out of high school, I worked on some very interesting projects. We were just trying to figure out what transistors could do. So we did things like dumping them in liquid nitrogen and see what happened to their characteristics at very low temperatures, and put them in various types of circuits to see what kind of frequency they might be able to handle and this sort of thing. So we were just trying to find out I was working with a professor from Cornell, and we were trying to figure out just what a transistor might be capable of. It was really a fascinating experience.
Yes, well, that was, considering you were just freshly out of high school, that must have been a real opportunity to do work, you might say, on the frontiers.
Oh, yes, it was really great.
Fine.
In fact, I think I was probably there was a period of time when people learned vacuum tubes, and then they learned how all the circuits worked with vacuum tubes, and then figured out how they worked with transistors and how to make the conversion.
Oh,
so
yeah.
I learned all these things with transistors first. So I was probably the first person to graduate from MIT where I had to figure out, I knew how they all worked with transistors, and I had to translate how they might work with vacuum tubes.
Oh, that's
do it backwards.
That was very interesting then. So at the end of that summer, then you went directly to MIT and enrolled. Care to give any of your impressions of MIT and your experiences there?
Well, it was the first time I really lived in an urban environment after spending all my time in the relatively idyllic surroundings of Oak Ridge, Tennessee, and then living in kind of the part of Cambridge that wasn't exactly the best place to live in the world at that time. It's improved considerably since, but I had to go through a little bit of culture shock to get used to the city environment and that sort of thing. But I eventually adapted to that kind of environment.
Yes. Well, do you remember any impressions of your first year's courses there?
Well, one thing that was kind of an interesting phenomenon that I'd gone to a public high school, and when I arrived, I found there were all these kids who'd gone to private schools who all knew they already had a lot of calculus, and of course, I had no idea what calculus was at that point. It was kind of an interesting phenomenon how I worked very hard because I didn't know what this stuff was. All the guys from the private schools, just kind of were breezing through. But see, that their knowledge carried them about 6 weeks into the course, and then they got a new material, but they didn't realize it.
Oh, yeah.
And so there was this phenomenon of us hard-working types from the public schools. We were sort of used to working hard, and we were quite frightened by the whole thing. And we actually wound up doing much better than the people who had the advanced knowledge, just because it got beyond them. It got beyond the background they'd had rather quickly, and they weren't able to adapt as quick as us who had started working very hard right from the beginning.
Yes, well, incidentally, of course, in high school, I believe you did have some experience working in a very competitive environment when you entered the math contests. And could you back up a little bit? Do you remember anything about the national math contests that you participated in, which involved problems of various difficulties?
Yeah, I remember. I always did pretty well on those. And, in fact, I got a book of Burrington's tables, which I still have to this day. That I pretty much wore that book out at MIT. Everyone at MIT had one, and I won that as a prize for doing really well in some of the national math contests.
Yeah. Well, that was, as I say, that was interesting about your early experience in math at MIT, and I suppose you took the standard chemistry and physics courses that everyone takes as a preparatory for your engineering career.
Right.
And as you went along, are there any other highlights of your undergraduate education that you can think of?
Yes, one thing that was really just a tremendous opportunity is I got into the so-called 6B program, which was Electronic Science and Engineering program. It was sort of an honors program in electrical engineering, and it was a phenomenal group of people. They were very highly selected, and there were only about, I think there were 20 of us or so. We took more or less the same courses, although we took quite a few graduate courses. I actually, by the time I graduated from MIT, I actually had almost enough courses for a master's degree, just going through that accelerated program. But there were about 20 of us. We were given an awful lot of work to do, but it was quite competitive. But we had all the best professors, and the training we got was just terrific. It was just a tremendous experience. I think that was really a great thing for me to get into that program and get the advantages of that.
Well, that's very interesting. You mentioned you had some very fine professors. Do you remember the names of any of them?
Yeah, Sam Mason and Zimmerman and Fano and Chu.
Oh yes, all that.
They really, all the top, and Louis Smolin, who was my advisor. But pretty much all the professors who were at the top of their field, taught us as undergraduates, and then that wasn't typical of the whole electrical engineering program. But,
you had certain advantages there. Let's see, was Dr. Wiesner, who was very active in the field, did you have any contact with him as an undergraduate?
Yes, in fact, I did a little work with him on my, we didn't actually have a thesis as such, we had sort of a thesis project, and I took some of the work that I'd done at IBM in logic design, and that was my kind of thesis project. It was again on computers, except this was now a whole arithmetic unit for the stretch computer was kind of the project I was working on at that time, rather than just a multiplier as I'd done in high school.
Oh yes, it was quite advanced over the simplified relay unit, you devised at that time.
Right. In fact, I continued to, all through MIT, I continued to work at IBM, during the summer. So I spent a total of 4 summers, and then most of it was involved with trying to introduce transistorized computers. And really, after the first summer was fairly general, and then the last 3 were all leading to the so-called stretch computer, which was the largest and fastest computer in the world, really for quite a while after it was built. It's a very ambitious project that IBM undertook to try to build a very large, all transistorized computer with some very, very tight specifications and very, very difficult performance requirements.
Yes, that was one of the first very large computers then that was developed.
Well, it was quite interesting. The kind of the concept was that the leaders of that effort at IBM recognized that the technology was moving rather fast. And so they took the approach to say, let's forecast how much transistors are going to improve and how much other circuits are going to improve. And then let's start today to build a very large-scale computer out of the components that we know we'll have 3 years from now. So we're trying to make a breakthrough. They were trying to make a breakthrough both in the design and also in the components. And it's very interesting. What happened is that everything improved at least as much as they thought, if not more, except the ferrite cores for memory. And they just didn't improve at all.
Oh, yes. And so the ferrite cores were the only things available, but greatly improved transistors were available at the right time.
Right. And the situation that caused is that essentially the transistors you had sort of a mismatch, because the transistors could do these calculations just at a tremendous speed, but you couldn't get the data out of the memory. So we got into some very interesting approaches to, I guess today you would call it parallel computing and pipeline computing, where we would do things like, we knew that if the answer ever came out of this ferrite core, it had to be either a 0 or a 1. So we'd do one whole set of calculations assuming it was a 1, another whole set assuming it was a 0, and then just chop. When we finally got the answer, we would sort of chop the 1 off.
Well, that's a very, very interesting concept. So the stretch computer then was completed, but its limitation was that of the ferrite cores.
Yes, we managed to meet the performance specifications, but it was, as I say, because of this mismatch between the memory and the basic computation circuits, it was a success in meeting its objectives, but it didn't turn out to really be, the best computer in the world because of this mismatch.
Oh, yes.
Although it's interesting that the whole 360 and 370 line really profited from that experience. And in fact, for many years, the whole line of the high-end large IBM computers all grew out of the stretch effort. In fact, most of the people who I worked with on that project, became leaders in that effort at one place or other.
Yeah.
So although stretch itself didn't work out so well, the survivors of stretch did very well within IBM.
Yeah. Who were some of the people that worked with you on the stretch computer?
Well, Eric Bloch was the guy I worked with the last year I was there, and the last year was probably the one that was the most profitable for me. And he really gave me a lot of responsibility for someone who was still an undergraduate at that time. And I really got a great deal out of that. And of course, he's now a major executive with IBM in charge of all their personnel and recruiting.
Oh, yes. Well, that was a wonderful opportunity there.
In fact, some others were, Barry Cradle was a professor from Cornell that I worked with, and Joe Logue and Bob Henley, who are also very high up in IBM management these days, were 2 other people I worked for at that time.
Oh, yes. That's remarkable. And then after you finished MIT, then, of course, your attention turned to graduate school, and how did you select what graduate school to go to at that time?
Well, during the time I was at MIT, there was a major event that I think had a lot to do with the development of technology over the next few years, and that was the launching of Sputnik in 1958.
Oh, yes.
In fact, I remember being at a dance at MIT, and they announced that the Russians had launched a satellite, and it's kind of an incredible experience. It was almost like everybody said, gee, we're the ones who can really counter this. We can, we the students here at MIT, we're the ones who can, build an American satellite and go out and compete with this. I mean, you could have probably, we almost linked arms and went marching off to start building rockets and satellites on the spot. It was really quite an atmosphere.
Yeah, so that was a very, very interesting reaction there, and in a sense, many of them did go on then into the space program.
Oh yeah, absolutely. Because I decided then that I wanted to kind of shift away from commercial computers like IBM was doing and try to find someplace in the space and defense business to get into.
Oh yes, fine. So then how did you arrive at a decision then for graduate school? Which university?
Well, one of my colleagues in the 6B program, a fellow named Colin Clive, who's a good friend to this day, he had spent I had spent my fourth summer at Poughkeepsie working at IBM. He had spent the summer between his junior and senior years working at Hewlett Packard out here in Palo Alto. And as part of that, he had spent quite a bit of time over at Stanford also. So he had found out a great deal about Stanford and Palo Alto, and I always had having been born in California, I always had a desire to come back. And when he told me about what a wonderful place Northern California was and everything, he pretty well convinced me that that's where I should go to graduate school.
Oh yes, well that certainly was a good choice because of the preeminence of the Stanford in the field of electrical engineering, primarily due to, I guess, Professor Terman, who was such an outstanding expert in both electronics and in education. It was a very fortunate set of circumstances.
Yeah, it was kind of interesting at that time. Stanford hadn't yet attained the reputation it has today, and in fact, they did quite a bit of recruiting. I mean, they sent some very, very good professors back to MIT to do recruiting, and they showed slides of the Stanford campus and the beautiful greenery and the girls walking around, and they showed these slides on the coldest day of the year at MIT with a big snowstorm. And if they'd hauled up about 20 buses in front of the MIT on that day, they probably could have taken the whole senior class with them.
Yeah, it's a very very interesting circumstances for recruiting, particularly.
I think they got more than 100 people out of my graduating class from MIT to go to Stanford, and I think that was just at that time. Stanford was just they were recruiting professors and students from from MIT and other places at quite a good clip. It was very interesting to see how fast that really established Stanford as a real center for electronics and electrical engineering.
Well, that's a remarkable story there. So you then enrolled in the graduate school at Stanford and started your graduate work. Do you have any particular memories of your first or second or third year at Stanford, and what some of the things that you did?
Well, one thing that was somewhat interesting was that after the fairly hard regimen I'd had at MIT, I was sort of amazed at how much easier things were at Stanford, and with the beautiful golf course and nice weather. I was able to take almost two full years worth of courses in 1 year. And I essentially finished all my graduate courses, except for 2 or 3 in the first year there.
Oh yes. Well, that made it very nice because then you could have more time for your thesis.
Right. That way I was able to get into my research really quite early because I really had an awful lot of the graduate courses already at MIT.
Oh yes.
And I couldn't get any credit for them at Stanford, but since I already had the material, I just simply took a double load. And that was since I already had the material, it wasn't that bad.
Well, good. Well, let's see. Then I believe, of course, you had experiences during the summer also. Would you care to elaborate a little bit on that?
Yes, I got a Hughes doctoral fellowship from Hughes Aircraft Company down in Culver City in Southern California, and I was very excited about that because of my interest in the space program and defense and this sort of thing. So I essentially, just as I worked at IBM in conjunction with my work at MIT for 4 years, I wound up working down at Hughes on every summer and then coming up to Stanford during the regular school year.
Oh, yeah. So you had a good chance to get work experience related then to your work at Stanford, which was certainly a fortunate set of circumstances.
Right. I started out designing computers. These were more, special purpose computers for, guidance on spacecraft and missiles and this sort of thing. And I actually changed fields a little bit around that time because that was kind of motivated by two things. One is while I was down at Hughes, they talked about entire defense systems, where the computer was just one part of the total system.
Oh, yes.
And I got very interested in systems engineering, control systems, and this sort of thing. And where the computer, the computer wasn't the whole thing. In other words, you weren't just building a computer to build a computer, but rather you were building a computer to be part of a total system, which might include radars and various sensors and missiles and various actuators of different types, and putting them all together.
So essentially, it was several aspects of electrical engineering brought together in this whole system, and each part then had to fit into every other part.
Right. I had to know about something about physics and aerodynamics and astronautics, and quite a number. I had to know a little bit about a lot of different fields, which was really quite appealing.
Yeah.
Then, kind of the other thing was that I heard a lecture from Richard Bellman, who's the father of dynamic programming. This took place my first year at Stanford.
Oh, yes. Was he on the staff at Stanford?
No, he came up and gave a guest lecture, and that was really that was probably the most impressive single lecture I've ever seen in my life. He came in wearing his white bucks and this rainbow jacket with about 30 different colors, and how he talked how he'd been on, that he'd almost missed his plane because he'd been out surfing on the beach in the morning, and he came in and gave this tremendous talk on dynamic programming and how powerful it was, and what the many things that it could do. And it's essentially dynamic programming is a systems technique that essentially allowed you to integrate together a lot of different sensors, actuators, computers, and it was kind of a general method for bringing them all together to accomplish some task.
Oh, yes. And I guess Bellman was a pioneer then in this field.
That's right. This was still fairly early in his career. His book on dynamic programming had only been out about a year. And, he was still, he was working at the Rand Corporation at that time, and, was still quite early in his career.
Right. And so, as I say, he'd only been in it a few years, and still he was a pioneer in this aspect.
That's right. Well, he had really developed the field almost overnight. It was quite an impressive achievement where a lot of fields, many people contribute a little bit here and a little bit there, and the field kind of, evolves over a number of years. And the area of dynamic programming, he sort of, developed the whole thing in about 3 years, wrote one book, that to this day still has, just a tremendous amount of information about the field in it, and just put it all together in one package. It was really quite impressive.
So, you got really interested in that as a graduate student. Then.
Right, and I decided about the nice thing about that technique is that it sort of integrated the systems ideas together with the computer. There were other ways of sort of trying to figure out how to design these systems and make them work, but dynamic programming was sort of uniquely dependent on the computer, and it sort of looked at everything through the eyes of the computer, and was very dependent on the computer as an integral part of this total system. And at that time, the idea of using a computer to control in real time, radars and spacecraft and missiles, this was quite far out at that time. But he really saw the future of the computer and really projected what it could do and put the entire theory there to do all these things.
Well, that was amazing. Well, then was dynamic program then brought into your thesis work?
Yes, I wrote my PhD thesis in that area. Essentially, what I was trying to do was the way Bellman had presented dynamic programming. It was an extremely powerful theoretical technique, but to solve even a relatively simple problem on the computers of that day was still rather difficult. So I developed some methods that essentially were computational algorithms that allowed you to take a somewhat larger problem and use that same limited computer but get a complete answer.
Oh, yes.
So it essentially reduced the computational requirements to the point where you could take a significant problem and get an answer to it.
Yes, well, and in those days, of course, the computers did not nearly have the capacity that computers today, and so some technique like this was absolutely necessary in order to solve the problem.
Yes, that's right. The technique was really wasn't a practical technique, with those computers, just to implement it in the more or less obvious way of implementing it. So, in fact, I've really kind of been stressing that area, the last 25 years, is just kind of improving upon this and trying to use the new computer architectures and the advances in computers to solve larger and larger problems.
Oh yeah. Well, then, as you mentioned, of course, your thesis involved this, and then you went on to finish up your thesis work, and then what was your next step after graduating and getting your PhD?
Well, I worked 3 summers at Hughes, and actually did quite a bit of consulting for them, during the year. And actually, it was interesting. The one project I worked on was optimal trajectories for the supersonic transport, which was, this was to be a Mach 3 aircraft that the U.S. supposedly was going to build.
Oh yeah.
And it was this was one of my first experiences with government contracting. There were a group of us who got quite interested, and we developed a very nice way to optimize the trajectory so as to minimize the fuel consumption of the SST. And since the aircraft was very high performance and burned a lot of fuel, this was really quite important. In other words, if you could save 10% of the fuel, it might make a difference as to whether the aircraft really was economically feasible or not. So it was, we had developed some very nice computer programs and algorithms, and so we thought, this might be kind of fun to start our own company, to spin off from Hughes, to start our own company, and do something like this. And this was kind of the first time I was exposed to the idea of starting my own company, and I was rather intrigued with it. Except a sort of a funny thing happened to us on our way to starting our company. Kennedy announced that the United States was going to definitely build an SST, and we thought, this is wonderful. This is just the best thing that could happen to us. The only problem, though, is that as part of this order to build the SST, he immediately froze all contracts, for a year, till they could kind of get organized. So the contract we were counting on to start a new company just was part of this freeze, never got let, and so we wound up never doing it. Well, it's funny, the guy I was going to do this with, my boss at Hughes Aircraft, was a guy named Don Richardson, who actually came to work for me later at Systems Control.
That's an interesting thing. Then, let's see, did you actually go to work for another organization in the meantime? Then.
Well, when I got out of Stanford, we clearly weren't able to set up our own company, and Hughes wasn't, despite the fact that Hughes had put me through their doctoral fellowship program. They weren't hiring at that point, so I was looking around for something that I had to find another opportunity. So by that time I had met Sue, and we were newly married, and she wanted to finish up. She had just finished her second year at Stanford and wanted to stay here.
Oh yeah.
So that highly made me a lot more interested in Bay Area companies instead of going down to Los Angeles to the aerospace industry.
Oh, yes.
So after looking around quite a bit, I wound up at Stanford Research Institute.
Oh, yes. What sort of problems did you work on there?
Well, actually, one of the motivations for going to work there is that I met Phil Merritt and John Fashon, they were the two I started Systems Control with, and I felt that they had the right orientation to perhaps start a company with someday. So that was actually a factor in my deciding to go to work there.
Oh yeah.
As opposed to a larger company, where there wasn't nearly the inclination to be an entrepreneur.
Yes. Well, then you did some work then on some of the projects at SRI for a while.
Yes, I first got exposed to the problem of ballistic missile defense, which is an area that I've worked on ever since. And,
oh yes.
I took some of the dynamic programming work that I'd done in my thesis, and I was able to apply it to several problems. One was a Kalman filtering algorithm for essentially trying to get the best estimate of what was happening to the trajectory of an object you were trying to track with a radar. I did some of the first work in really applying that theory to a real application of radar and reentry vehicles. And I worked out all that theory and took some real data and processed it and got quite good results.
Oh yes. So you had several large projects there that you could work on. You worked on at SRI, which expanded your work as far as computation and computers. Then.
Right. In fact, I got quite a bit. I got more into the systems area. Things like this filtering problem. I did some trajectory optimization for anti-ballistic missiles. I also worked quite a bit in the commercial area and on some problems in the electric power and gas pipeline control. It was a very, very interesting 4 years. I worked on quite a large variety of problems from a number of different fields.
And most of those involved using computers as a part of a whole systems analysis.
Right. Yeah, using this dynamic programming viewpoint, and by then computers were getting more and more established with more and more capability, and so I was always on the kind of the cutting edge of trying to take a computer and push it a little further and try to get it to be able to do more things as part of a total system.
Yeah. Well, fine. Well, then, of course, your next step in your career involved starting your own company, and how did that come about?
Well, we had managed to, when I came to work with Merritt and Fashan, I think there were 4 or 5 of us in this relatively small group, and over 4 years we were able to build that up to about 30 people. We had I hired some of my friends who were graduate students at Stanford, so we had people who were close friends and working together as colleagues, and we thought we had some pretty exciting ideas, and we made a lot of technological breakthroughs during that time. I finished my first book. I wrote close to 80 papers during that 4 years while I was at SRI. Really was it was a very, very fruitful time for research, and a lot of that was kind of the early days of systems theory, really, and control systems becoming an established discipline, and I was really on the forefront of that, and I attracted a lot of people from all over the country, and we built up this very outstanding group, and we thought, gee, if this is so successful within SRI, and of course SRI was it's supposed to be more of a quiet research institute, something that was growing rapidly like that didn't fit in all that well.
Mm-hmm.
So I kind of gotten the bug about starting my own company from working with these fellows at Hughes, and so I kept sort of talking about it with Merritt and Fashan over the years, fairly quickly after I was there, and finally in 1968 we decided to do it ourselves, and we started our own company, Systems Control Incorporated.
Yes, well that was of course quite a step at that time. Do you remember some of the initial problems and methods that you used to establish the company? And
well, we had to decide how to finance it and how to get started. That was a big problem. We looked at everything from putting our own money into it, which was, we didn't have that, none of us had that much money, and it was too risky, so we decided against that. We also talked to Jim Ling of Ling Temco Vought, and he says, well, when you're doing $10 million a year in business, come back and see me.
Oh, yes.
So we finally found some people in between, who were more interested in maybe helping us get started, and that's when we met Dick Miller of Wolf & Company.
Oh, yes.
Which is a Chicago-based accounting firm. We were about the right size, for him to provide the financing for us. He also had some hopes that we could apply some of our ideas, which had been applied mostly in a defense context and to some extent in electric power and utilities. He had a real interest in applying us into some of the business areas.
Oh, yeah. So then you were able to get enough financing from Wolf in order to get started then.
That's right. So that provided our initial financing and basically got us off the ground. We had a few tight moments during those early years. We managed to take a couple contracts with us from SRI that we were the key people on. They weren't that interested in trying to bring in new people to take care of them. So we took we took a couple contracts with us, but then we had to go out on our own and try to bring some things in. And, it was very exciting. We finally got an initial contract in ballistic missile defense and another large initial contract in the electric power area, and we were kind of off and running.
Oh yes. Well, that's so those contracts served as a basis then for your further expansion into the field. Well, how as you went along, what are some of the major developments that you participated in your systems control corporation?
Well, the defense business got to be quite large, and for quite a while that totally dominated the company. And I guess during my years of systems control, I sort of worked across the board. I was more the technologist, in the group. So I tried to open up new technical ideas in the defense area, and I also did a lot of fundamental work in electric power, which became the second largest area in the company, and got a lot of good research done on that, and just generally kept the company moving forward. And we grew from 1968 till we sold the company. We grew from 3 people to over 500 people. Our volume of business went from $300,000 a year up to almost $40 million a year.
Yes, well, that was both that was exponential growth in both personnel and dollar volume.
Right.
Right.
Yeah, and through all that time, we were profitable every year, and we never had to get any outside financing. The initial financing we got from Wolf & Company turned out to be enough to get us through. We never had to borrow any. We never had to get any outside financing. We borrowed money against contracts that we had, but never had to get any additional equity into the company.
Yes, well, that's a rather rare thing. I believe Hewlett-Packard is another example where they essentially did their own internal financing like that,
right.
And it makes for a great deal more flexibility and soundness of the organization financially.
Right.
Well, that's so. Then the business kept growing, and you took on more and more diverse fields. What is it? Electric power systems and
electric power grew. That grew quite rapidly. The environmental area, we got that became kind of a boom area for a while, and then kind of faded away. And we got some of the early contracts in that area and grew with that, and then kind of phased out of it. But we generally kind of tracking new technological areas as they came up and trying to apply computers and systems theory to these various problems.
Yeah. Well, that's a remarkable story of growth in there. And then, what was the next major step in your career there? Then,
well, during that time, I actually almost from the start of when I left MIT, I got quite active in the IEEE. This is the Institute of Electrical Electronics Engineers, and today it's the world's largest professional society with 250,000 members worldwide. And essentially I started out as an editor of the Control Systems Society Journal, and worked my way up to be president of the Control Systems Society, then got on the board of IEEE, and eventually became vice president in charge of technical activities. In 1982, I became the president of IEEE.
Yes, let's see, along the line there, as a result of service to IEEE and also professional advancement, let's see, I believe you did receive some awards in the field.
Yeah, I received several awards. I guess as early as 1965, I received the Best Paper Award from the Transactions in Automatic Control. And in 1968, I received the Donald P. Ekman Award for Outstanding Achievement in the Field of Automatic Control. In 1969, I was named by Ada Kapanou as the Outstanding Young Electrical Engineer in the United States. Oh yes,
well those are remarkable professional excellence acknowledgments, and
Yeah, it's interesting. They have a lot of awards for people around 30 years old, and they have a lot of awards for you at the end of your career, but you can't seem to find anything in between.
Nothing in between. That's an interesting point. Well,
so I guess I have to wait another 15 years before I get another award.
Yes, well, that's a very interesting story. And then that particular about that later on, I believe several companies got, as usual, got interested in acquisitions. And do you have any? I believe you probably have interesting stories in connection with acquisitions, so to speak.
Yes, we had grown quite rapidly. We were starting to get some very large contracts. We got one contract I guess there were two contracts, one from the state of Maryland and one from the state of Washington to do environmental testing. That was kind of an outgrowth of some of our environmental work. We actually got into better ways of modeling automobile engines, and that kind of led us into testing automobile engines for emissions. And as you know, the EPA mandated large statewide programs for testing automobiles to make sure that their emissions control equipment was working properly. We got these two contracts, which the total value of the contracts is, like, the state of Washington is about $25 million, and the state of Maryland is about $70 million over quite a few years. And so we started contracts, and as a result, it was.
Sorry, are you stopped? Go ahead.
So the contracts were getting larger and larger as we were going, and the things we had financed everything, on our retained earnings and borrowings, and we kind of found ourselves in this awkward position where we could get very large contracts, but we couldn't really finance them. We were also starting to get into the international market. We had jobs in Saudi Arabia and South America. We had a job in Egypt for about $12 million, one in Colombia, South America for about $15 million. And these jobs were just more than we could easily finance just on this basis. So we started looking around for some way to take advantage of it. We had the ability to win these jobs, but not to finance them. So we started looking for some way to continue capturing them, and then the thought of being acquired by a larger company kind of occurred to us at this point.
Oh yes, so that you reached that point where essentially you were too successful to be able to finance the big expansion. So
right. Yeah, and it was we just couldn't leave those good opportunities sitting on the table.
Oh, yeah.
We really wanted to take advantage of them, but there was no way we could, just with our limited financial resources.
Yeah. Well, then, what happened next in your next step then?
Well, we had talked to 2 or 3 companies about acquisitions and had relatively serious talks, although we hadn't really brought anything to fruition. And that's when British Petroleum came into the picture. They had actually acquired a company called Sycon. I don't know if you remember the old. There was a large service bureau operation in the United States back in the early 60s that had a European operation. And Control Data Corporation bought the American part, and then British Petroleum bought the European part. So they were using the service quite extensively to run some very large linear programs on. So they bought the service bureau and started a company called Sycon. Over time, to the service bureau operation, they added kind of a consulting arm, which became very much like systems control was, in terms of doing studies and building computer systems.
Oh yes.
So they felt that they had always wanted to get into the American market. They had tried a couple of small offices and never been able to do it themselves, and they saw that we had these opportunities and we had a critical mass of people, and we were very successful not only in our studies, but by this time we had grown to we were actually doing turnkey computer systems, quite a large size in a number of different fields. So they felt that it was a logical acquisition for them. So they essentially made us an offer we couldn't refuse.
Yes, well, that was an interesting match. You were just your need for finances and their needs coincided then.
Right. They had actually profiled the kind of company they wanted to acquire in the United States, and we were their first choice. We fit the profile the best.
Oh yes. Well, as you say, that was you could hardly resist that particular opportunity then.
Right, right.
Fine.
So, well, they bought us in early 1981. I stayed with the company another couple of years. Basically, during 1982, that was pretty much full-time president of IEEE.
Oh yeah, so that took a great deal of your time.
Yeah, that really was a full-time job. I mean, when I wasn't traveling somewhere, I was back there trying to go through mail and things. So it really turned out to be a full-time job.
Oh yeah.
But that was quite an experience. I traveled over 300,000 miles, went to 35 countries, and met electrical engineers from all over the world, and it was really, really just a great experience.
Yes, that's a very, very rare experience that you had with that.
Yeah, I gave over 200 speeches and all sorts of topics.
Well, that's a fascinating thing. Well, then, when you finished your your tour of duty, so to speak, as president of IEEE, then you looked at you might say other expanding opportunities.
Right. When I came back from essentially having spent a whole year as president of IEEE, there's kind of two traditions in America. One is that if you're acquired by a larger company, you lose your job after a couple of years. And another tradition is that if you take a year off to be president of IEEE, you lose your job when you come back.
Oh yeah.
In fact, that happened to all four of my predecessors, by the way.
Oh yes.
So with those two traditions going for me, it was pretty clear that I needed to look around for some new worlds to conquer at the end of that time. And sure enough, when I came back, it became clear that I needed to find something else to do.
Yes. Well, that as I say, of course, with their particular new management, they have different objectives, and particularly being a foreign country, a company in a foreign country, it was with different ideas of management and so on. Then, as you mentioned, you had some other ideas
right.
as to where your career would lead next.
Right. So I looked around for some things to do. Of course, throughout all the time I've been a professor at Stanford. I've been a consulting professor in the Department of Engineering and Economic Systems, and I thought about becoming a professor full time. And by this time, I'd written 140 papers and 4 books, and really got to be quite an authority on dynamic programming. And I teach a dynamic programming course at Stanford, so I thought about doing that full time, and I still stay involved with that. Also during that time, I was still active on this commission on pre-college education in science and mathematics, sponsored by the National Science Board. That was another quite interesting experience, trying to address what the ills of the American education system were, particularly in the high school level and in science and mathematics.
Yes, that must have been quite an experience to go through that very vexing problem and very important problem. But eventually you came to finish that up and write the report, which is, of course, very well received in many parts of the educational system.
Right, that was one of the few government commissions to actually turn in its report a month early. I think that's almost unprecedented.
That's almost unheard of there.
And actually, that was quite. It was really interesting because I really saw the best of American education in high school and through Sputnik and those times. That was sort of the heyday, when education in science and mathematics was really emphasized. Where you almost a hero, if you worked in science and math. And I saw how that had deteriorated over the years. So it was very interesting to have lived through all that and then have a chance to kind of look at some of how we need to rejuvenate that part of our educational system. We came up with some really good ideas, I think, and we have some hopes that some of those will get implemented.
Yes, I believe some of those things are already being implemented in some of the more progressive systems in the country.
Right. Well, but of course, being on a government commission and being a professor neither one of those was a good full-time job, so I had to find something else to do to earn a living. And I actually started 3 things, more or less about the same time. one thing is, I'd always sort of wondered what an ex-president of IEEE might, be suited for doing. And I traveled all over the world, and I talked to, heads of state. I talked to billionaires. I talked to electrical engineers in every field imaginable. I had all this great insight into technology and economics and the marketplace. And it occurred to me that, gee, maybe venture capital was an interesting area.
Oh, yes.
So I got involved with a venture capital fund, and that gives me a chance to look at a lot of different companies and try to figure out which ones have a good chance of being successful. And so that was one opportunity I took up. I also started two companies. One is a software company called Optimization Technology Incorporated, which is working on particularly on software for defense and other applications. And I also started a hardware company, Visidata Corporation, which is working on low-cost computer terminals with an eye towards eventually building workstations. And they're also working on components such as power supplies and keyboards.
Oh, yes. So now you're into both hardware and software in certain specialized areas. Then.
Right. So I like to say that I've got three companies: a hardware company, a software company, a venture capital fund. And the hardware company churns out the products, the software company produces software for it, and the venture capital company keeps them both in business.
Oh, yes. That's very, very interesting thing. Well, I think that really brings us up to date in most of the important parts of your career, and I was wondering if you cared to say perhaps a few general words on, might say, professional societies like the IEEE, education, or how you view the future in the field of electrical engineering, or any miscellaneous thoughts you might have.
Well, I started looking at everything I've done. I've noticed there is one common theme is I tend to get really dedicated and very excited about something, almost take on a crusade. Mm-hmm. And I sort of wonder why am I always doing that? And sort of looking back, I can really I think Oak Ridge was maybe one of the biggest crusades on a national level that we've ever seen. Where we brought together all the scientists in the whole country, really in the whole free world, together to build the atomic bomb. And it was a tremendous achievement. Just in a few short years, we went from a theory to a real weapon that you could do things with, and on to atomic power and all these other things. I think that really shaped my whole life. I mean, that to kind of grow up in that atmosphere, of people, people just absolutely dedicated, to achieving a goal like that on a truly national and really international basis. But when I look at when I was working at IBM on the stretch computer, that was another crusade, to try to build the biggest and fastest computer in the world. The whole space program with Sputnik and getting involved with that, to put a man on the moon by the end of the decade. Trying to revamp our education system, make it the best in the world. I guess that's, and when I started Systems Control, I wanted that to be the first systems company, really built on control theory and dynamic programming and systems theory, and to really build the first company around that ever existed, which I was successful at. So I guess that's kind of the way I've approached things, and I think it has to do with kind of growing up in that atmosphere and having the opportunity to be associated with many ventures like that had great national and international impact, and I hope I can continue to do that kind of thing throughout the rest of my career.
Well, that's a remarkable exposition of, you might say, the motivation that leads to these different accomplishments, and certainly sets a pattern which, they say, can serve almost anyone in the highly technical area, showing that there's always new frontiers to conquer, so to speak.
Oh, absolutely, yeah. Certainly with the progress that's been made in computers and the new things you can do with them, there's just constantly new opportunities, to take things, advance them further, and apply them into new areas where they've never been before. And it's just, I think the future looks as exciting today as it ever has over my whole career.
Well, I think that's a very, very interesting exposition of the role of science and technology and its relation to even national goals. And I certainly want to thank you for that very clear exposition of this whole subject and how your life related to it. And I think this will be very, very useful in having scholars look at the aspects of science and technology and how it really yields results. So thank you very much for this excellent presentation, and congratulations on a very clear-cut explanation of those things which you've been involved in.
Thank you.